Integration of inverse trigonometric functions. So in week 8 we looked at differentiating our inverse trigonometric functions. So here when we differentiated our inverse sine of x, we got 1 over the square root of 1 minus x squared. So working backwards, what we need to do is to get our integral into this format here. So we may need to do some manipulation to our formula to end up at this point, and then go through to integrating and get our inverse sine of x plus our constant c. Same with our tangent function, our inverse tan of x, 1 on 1 plus x squared. And so again, we're going to be manipulating our function to get it in this format here, so we can go through and get our integral, which will be our inverse tan of x plus our constant c. So we'll put our formulas as we go through as they appear on our actual formula sheet here. So here we want to integrate the following function. So if we look at our formula sheet, here we have d on dx of our inverse sine of u is equal to 1 on 1 minus u squared du on dx. So we look at this and we go, well, we're kind of in this format, but we have a 4, not a 1, don't we? So what we need to do is to get rid of that 4. And if we take the square root of 4, we're going to end up being equal to 2. So this can be the same as a half times 1 on the square root of 1 minus, and now we've got to take, well, we've taken our, just get rid of that one. So here we've multiplied it by a half, and so what we're going to have to do is also multiply this by a half here, squared. So here we have, now we're in this format here. Our u is equal to a half x, and we have our 1 that we need here. 1 at the top, so apart from this here, our u, we're doing pretty well. So our u is equal to a half x, so du on dx is therefore equal to a half. So what we need to do, we're going to have this half involved as well. So if we multiply here, we'll put it in red so we can see it here, so we could multiply by a half here, and we get a 2 out the front here. So it's a half times 2 there. So if we write it out to make a bit more sense, so our integral here, we've got a half times 1 on square root of 1 minus a half x squared here. So first we move our half out the front. So it's a half times the integral of 1 on 1 minus a half x all squared here, dx. So we need our du dx in there here, which will be here a half. So multiplying by a half, and then at the front here multiplying by 2. So now we've got a half times 2 is just equal to 1. So here we've got our integral of 1 on square root of 1 minus a half x all squared is equal to here, so we now in exactly this format, and we put our u in, so it's our inverse sine of u is a half x plus our constant c. So looking at the next example here, if we write out our formula as it appears on our formula sheet here, so we have our d on dx, our inverse sine of u is equal to 1 on square root of 1 minus u squared du on dx here. So now if we look at this, well, we've got here 9x squared. We want to make that here something, so 9x squared is equal to something altogether squared, and we know, well, the square root of 9 is 3, 3 squared is 9, so it's the same as here in brackets 3x squared. So that's our first step here, 1 minus 3x all squared. So we're getting into, we've got this format here. Now we need to differentiate our u. So we know, well, our u is equal to 3x. du on dx is therefore equal to 3. So now we need to, we'll draw our integral here. We've got 1 on root 1 minus 3x all squared dx here. So we want to take this this differentiated 3x here into account. So we're multiplying by 3, and out the front we can divide by 3 or times by a third. So now we're in our exact format here to go backwards. So here it's equal to a half. Our inverse sine of u is 3x plus our constant c. So for our next equation here, we notice, okay, we don't have the square root at the bottom, so this will be our tangent, inverse tangent function. So d on dx, our inverse tan of u is equal to 1 on 1 plus u squared du on dx. So we're pretty close here. We're just going, well, we've got a 4, here we've got a 1. So what we can do is take a quarter out the front. So it's a quarter times, so our 1 stays the same, and here it's going to be, well, 1 plus it's going to be a quarter x squared. And here, well, the square root of a quarter will give us 2. So 2 squared gives us 1 on 2 squared, a half squared gives us a quarter. So this one will become a quarter times 1 on 1 plus a half x all squared. There. So now we've got here our u. U is equal to a half x. So we differentiate our u here and we get a half. So what we're going to do, we'll write our integral up. So here our integral, we've got a half times 1 on 1 plus a half x squared here. We move our half out the front. So it's a half multiplied by the integral of 1 plus a half x all squared dx here. And we have here our du on dx is equal to a half. Here. No, sorry, 1 on 4, we lost that 1 on 4. So 1 on 4 is out the front here. So here a half, so we're going to multiply it by a half. And to get that half times 2 is equal to 0, so we're going to multiply here by a half. And by 2. So now 2 times a quarter will give us a half. Our integral here, 1 plus a half x all squared multiplied by a half dx here. So that is our format exactly as we have it here. So it's going to be a half inverse tan of our u, which is a half x plus our constant c. Okay, so moving to our next question here. We've got again our tangent function. So we'll write our equation from our formula sheet at the top. We have d on dx, our inverse tangent function here of u is equal to, here 1 plus u squared du on dx. So this one actually looks pretty good, doesn't it? We have our 1 and we have, well, 9x squared. So we say, put here, we've got 9x squared is the same as 3x all squared. So now our formula becomes 1 on 1 plus 3x all squared. So our u is now equal to 3x. We differentiate our u with respect to x and we get 3. So we need to bring that 3 in here. So we're going to write our integral up. We've got 1 on 1 plus 3x all squared. And so now here we've got our integral 1 plus 3x all squared. And we're going to put in here our du on dx. We're going to multiply by 3 here and a third out the front. So we have this format here. This becomes equal to a third our inverse tan of u, which is 3x plus our constant c. Okay, looking at our next question. So here we've got our square root at the bottom. So we're going to write out, we have no negatives involved. So here we're going to write here our d on dx. Sine minus 1 of u is equal to 1 on square root of 1 minus u squared du on dx here. So now we look at this and we go, well, this isn't very nice at all. We can look at our 2x minus x squared. We can take x out the front, but that doesn't really help us with this. And what we're going to be looking at here is we want to complete the square. So what we want to do, we want to complete the square. Then we can get something in this format here. We want to get something that's going to be our u squared. So if we work over here, if we've got 2x minus x squared here, and we want to end up with a 1 minus, so our signs aren't super important at this point. We just need to know we want opposite signs. So now we go, well, to get that, if we did x, and if we did plus 1, we're going to end up with the same signs, but if we do minus 1, we're going to end up with different signs. X minus 1 squared is going to give us x squared minus 2x plus 1. So here we've got our 2x minus x squared, and here we've got our x squared minus 2x plus 1. So if we take if we take a minus out the front, so here minus out the front, here we're going to end up with minus x squared plus 2x minus 1. So this part is all the same. X squared plus 2x, we've just got a minus 1. So this one, if we add 1, we end up with exactly what we have on this side here. So now what we end up with here is 1 minus x squared. We'll write the whole thing out. We'll write it over here. So here we're going to have 2x minus x squared will be the same as 1 minus, because we've already multiplied this by a negative here, x minus 1 all squared. So all of that work, and we've ended up with this one here. So this becomes, putting back into our equation here, 1 on square root of 1 minus x minus 1 all squared here. And we can go through those steps and just make sure we got that correct as we go as well. So now when we look at this here, we've got this in our format that we need here. Our u is equal to x minus 1, so du on dx is equal to 1. So we are exactly in the format that we need this to be. So now here we integrate. We've got 1 on the square root of 1 minus x minus 1 all squared dx. So here it's going to be our inverse sine of u, which is our x minus 1. Inverse sine of u, x minus 1, plus our constant c. So moving on to our next equation, we're going to be going through the same sort of thing. We've got our square root sign at the bottom, so we'll write our formula out for our inverse sine. d on dx, our inverse sine of u is equal to 1 on square root of 1 minus u squared du on dx here. So here we've got 4x minus x squared minus 3. And we think about what we need to do that, and we're going to have a 1 minus out the front of it, or we want to end up with a 1 minus, so we can put a negative in front of whatever we're working with. So it's going to be an x here, and then to get to 2x. And here, and we've got opposite signs. We have a minus and a plus, so we're going to say minus 2. So here, x minus 2 all squared is what we're looking at here. That will give us x squared minus 4x plus 4. So we're going to take our negative out the front here. Will give us minus x squared plus 4x minus 4. We go, well, here our minus x squared is good, plus 4x is good. We've got minus 3. So what we're going to have to do is add 1. So this is the same here. If we have x minus 2 all squared, and we had a negative for that one, we already put that in here, plus 1, or 1 minus x minus 2 all squared. Now we're in our format that we can use. So we have 1 on here, square root of 1 minus x minus 2 all squared. So if we integrate this, we've got here 1 on square root of 1 minus x minus 2 all squared. Again, we can see our u is x minus 2, du on dx is just going to be equal to 1, so we can just work straight through with this here, and it's going to be our inverse sine of our u, which is x minus 2 plus our constant c. That's a 2. Okay, so if we move on to our next example here, we're doing exactly the same thing here. We're just working with slightly different numbers. So here we've got 1 on 2 plus 2x plus x squared here. So our first step is we want to complete the square. And we've got, well, 2 plus 2x plus x squared. They're all the same sign. So we know, well, it's going to be positive here. X plus something all squared. So to get to 2x and 2x plus 1 all squared will give us here x squared plus 2x plus 2. So we don't even actually have to do anything with this here. Or plus 1, sorry, plus 1. So now to get to 2, we're plussing 1 more. So it's going to be equal to 1 plus x plus 1 all squared. So we write this one out. It's going to be 1 on 1 plus x plus 1 all squared. And we didn't write out our formula. We said there's no square root at the bottom. So we're going to use our inverse tangent function. D on dx, inverse tan of u is equal to 1 on 1 plus u squared du on dx here. So x plus 1 is our u, du on dx will just be therefore equal to 1. So we don't have to worry about that one here. So we're going to go here, we want our integral of here 1 plus x plus 1 all squared here, and so it's going to go through here. We're going to have our inverse tan of x plus 1 plus our constant c. So now on to our last example here. First of all, we start by writing here, we don't have a square root at the bottom, so we'll write out our tangent function here. D on dx, inverse tan of u is equal to 1 on 1 plus u squared du on dx here. So now we look at it, we have here 5 minus 4x plus x squared. So we have different signs, so we know it's going to be x minus something here. So here we're going to have, to get to minus 4x, we're going to have x minus 2 all squared. X minus 2 will give us x squared minus 4x plus 2. Sorry, plus 4. There we go. That makes sense. Plus 4 here. So now, okay, to get to this, we're going to put in here, we want to have, these need to be negative, or 1 plus, so these are fine. These are right, signs are right. And here we need plus 1 more. So here our 5 minus 4x plus x squared, 5 minus 4x plus x squared is the same as here x minus 2 all squared plus 1. So we write this out here, becomes 1 over 1 plus x minus 2 all squared. So now we integrate here, we've got 1 on 1 plus x minus 2 all squared. Here we don't have to do anything further with our function here. Our u is equal to x minus 2, so du on dx will then be equal to 1, so we don't have to do that. Where we end up with our inverse tan of u, which is x minus 2, plus our constant c.